Prior to observation, matter does not seem to exist. Matter seems to be the result of an interaction between consciousness and waves of potential. This has been demonstrated repeatedly in ever more precise versions of the double-slit experiment, from the 1920s right up through the present. To understand the double-slit experiment, we first need to know how particles behave. If we shoot small objects at a detector, we will see a clump pattern form where they went through the slit and impacted. If we add a second slit, we would expect to see a second clumping duplicated to the right. Now let's look at waves. The waves go through the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the clump pattern. But when we add the second slit, something different happens. When the top of one wave meets the bottom of another, they interfere and cancel each other out. This results in an interference pattern on the back wall. Where the waves reinforce each other, they are at the highest intensity, the bright lines. And where they cancel each other out, there is nothing. So, when we fire objects through two slits, we get two clump patterns, but with waves, we get an interference pattern. An electron can be seen as a very small bit of matter. And when a stream of electrons is fired through one slit, they behave like small objects, forming a single clump pattern. So if we fire these bits of matter through two slits, we should get two clump patterns. But we don't. We get an interference pattern. We fired particles through, but we get a pattern like they're waves, not like little objects. How can pieces of matter create an interference pattern like waves? It doesn't make sense. At first, physicists thought that the electrons were bouncing off each other to create this interference pattern. So, in 1961, Klaus Johnson at the University of Tübingen in Germany modified the experiment to fire the electrons through one at a time. This way, there is no possibility of them bumping into and interfering with each other. But again, the interference pattern was seen. Physicists were perplexed by this.
It somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both?
The path taken by the photon is not an element of reality. We are not allowed to talk about the photon passing through this or this slit. Neither are we allowed to say that the photons pass through both slits. All this kind of language is not applicable.
So they further modified the experiment to get to the bottom of the mystery. They put a measuring device at one slit to see which one the particle actually went through. But when the electrons were being this closely observed, they went back to behaving like little objects and produced a clump pattern, not an interference pattern. Somehow, the act of observation meant that they only went through one slit, not both. The electrons seemed to decide how to behave as if they were aware of being watched. How could this possibly be the case? Could the presence of a conscious observer be influencing the experiment?
Consciousness is information. It's an information field. Okay? It's data.
In 1978, physicist John Wheeler proposed a new way of doing the double-slit experiment that might finally reveal what's really happening. He proposed what is called the delayed choice experiment, in which the decision of whether or not to observe the particles isn't made until after they have gone through the slits, but before they've impacted the detector. This animation is highly simplified, but you get the idea. Here comes the light. It travels through the double-slit barrier as waves. The waves are past the slits but haven't yet hit the detector. And here comes the scientist. His eyes are closed. He's delaying his choice to make this an observed experiment. And then... The results of the experiment didn't solve the mystery. Instead, it got even stranger. Because what was found was that at the moment of decision to observe, the waves became particles. And not only that, but they actually made a record of themselves as having traveled through the slits as particles. Yes, you heard me. Deciding to run the observed experiment causes the waves to become particles, and this causal force extends backwards in time.
Our choice of what experiment to do determines the prior state of the electron.
Running the experiment unobserved does not cause this effect.